which will give me a little bit more than I need. And then I'm going to fill that to the 60 milliliter line with hexanes, and you'll see that it'll build up some heat, a bunch of bubbles, and then we stir that to make a slurry. So we're getting rid of all the air bubbles. And that's what we'll be pouring down the column. 100 ml beaker underneath. I'm going to wet the sand a little bit by pouring just a little hexane in. Make sure there are no air bubbles in the sand itself. And then we pour this slurry in, trying to help the silica out as much as possible. Kind of scoot that out of there. We're shooting for a column that goes just underneath the blue labeling where it says quark. And once it starts getting a little too thick, I'll just dump some hexane back in so I can make a better slurry. And kind of tap it, help it settle. I think that's going to be enough once it settles properly. So I'm going to try to wash the silica down the walls. The goal is to have as few air bubbles as possible, because an air bubble can crack the column, and a cracked column doesn't separate very well. So I'll give that a little tap tap. Looks like I do need to add a little bit more. Didn't settle quite as much as I was expecting. That works better. TLC might be about done by now. Yep. Ran that slightly off the edge, I think. So we'll let that dry for a minute while I finish this. Pretty vigorously. We want that to settle. Before we add the sand to the top, so that when we add the sand we don't disturb the top of the layer. So it looks like I'm about halfway up the blue labeling. And we'll just put a little sand on top after we've kind of washed down the silica, so there isn't silica on top of the sand layer. And the goal is to just create a thin layer of sand to protect the top of the column, so when we add our product it doesn't disturb it. Slap that around to get that to settle as well. And this can just evaporate for later. At this point I'm going to stop the flow. By adding a number 13 stopper to the bottom and a number 19 to the top. Add the 19 to the top first, because I don't want to push air up into the column, and then stop it with a 13 on the bottom. So that column will sit there and be ready, and we're ready to use it. There's no way to pour a column without getting silica everywhere, so that's just part of the game. So this is nice and dry. And we can take this over to our phospholiptic acid. That should be hot enough that when you hold your hand like an inch above, you can definitely feel the heat. And I'm going to hold it by the end where I spotted so I can get the whole thing submerged. And we submerge that up to the line. Pull it out and drain as much as possible out onto the back into the jar. And we want to dry that off before we put it in there. It's very important to put the cap back on right away. This is a 28% solution. There's a lot of phospholiptic acid. If you spill that, it will take huge amounts of solvent and paper towels to get that back under control. I'm going to make sure it's nice and dry on the back. And you'll see this kind of a chartreuse, pretty dark colored chartreuse. And now I'm going to hold that over the hot plate. And if I get it too close, it'll start to bend a little bit. Sometimes it's better to hold the silica side down. And I will actually rest the forceps on the hot plates. What I don't want to do is accidentally touch the plastic to the hot plate and burn it and melt the plastic. So it takes a little while to develop. But you can see that some blue spots are starting to come down at the bottom there. You also see that it looks like it developed pretty crooked once it got going. Let me just let that go until we look like we have nice color development. Probably what happened is this edge was touching the wall of the TLC developing chamber, so as the solvent came up it started wicking that direction as well. So that's a relatively inconclusive TLC plate. Looks like we got a dark blue spot down at the bottom. That dark blue spot is likely to be our product alcohol. Why it looks like we're seeing some of that dark blue spot in the ketone is unclear to me. There should not be any alcohol in that ketone, but it's also possible that it got contaminated. And the ketone, one would expect to be up here somewhere, but it looks like it may have gone right off the edge of the plate. But at any rate, what I'm trying to do is I'm trying to get the RF value of that spot so I know which spot I'm looking for. You see, it looks like there are two spots there, and that may be because there are cis and trans isomers of this alcohol, and we're going to be making both of them. One is much more prevalent than the other because of the way the Grignard reagent adds to the ketone. So we'll leave that TLC plate sitting. So that'll tell us that we're looking for a spot, down there with the RF of maybe, I don't know, hard to say since I ran it off the edge, but maybe 0.25, 0.3-ish, something like that. So we can set that TLC chamber aside for a bit. So I have my column poured, and I need to make up two solvents. I'm going to be making 100 milliliters of a mixture of hexane and ethyl acetate It's 85 hexane to 15 ethyl acetate. And then I'm going to be making 50 milliliters of a 9-to-1 mixture. So we got 50. And another 35. And then in the other one, I'm going to be making 50 milliliters of a 9-to-1, so 45 to 5. So I'm pouring 45 milliliters of hexane in there. Mostly used up the bottle of hexane. And I'm just going to use the same graduated cylinder for the ethyl acetate. So I want to put 15 milliliters of ethyl acetate in there and 5 in the other one. Put a watch glass on there so it doesn't evaporate. Let that evaporate in the back. So just stir that to make sure it's well mixed. Here's our 85-15 mixture. Here's our 90-10 mixture. We're going to be running what's called a step gradient. So we're going to be running 50 milliliters of pure hexane through, followed by the 50 milliliters of the 9-to-1, followed by the 100 milliliters of the 85-15 or 8.5 to 1.5. And I'll just set that aside for now. Once this evaporates, I'm going to return the silica to the stock bottle. I'm going to apply some air pressure so this goes faster. And for that we use a vacuum hose attached to the air. And we don't want it to be really high pressure, but we want to be able to hear it when we release. So you can barely hear it until you stick your thumb over it. And then you see that pressure. So that's about the right pressure. So let that sit. I'm going to collect 8 milliliter fractions. So I want to measure 8 milliliters into that test tube. And mark it so I'll know how high to fill the tubes, and then I'll just fill them all to the same level. These hold about 10 total, so there's my 8 milliliter mark. And you'll see it's not far from the top. And we can measure that, and we're basically Filling it to about 3/4 of an inch from the top, 7/8 of an inch from the top, something like that. So I need 50 milliliters of hexane total. For the initial run, some of that will be from there. So I will need another bottle of hexane. So I'm adding about 40 milliliters to the beaker. I figure I got about 10 up there. That should be about right. And I want to measure the actual length of the column. I was shooting for about a 6-inch column, and it looks like I'm very close to 6 inches. Right? Almost exactly 6 inches, in fact. So we get a column that's 6 inches long, or about 15 centimeters long, and then the inner diameter is approximately 2 centimeters. So we'd want to report that as a 2 centimeter by 15 centimeter column. So we're set. We've got our air pressure, we've got our rack of test tubes, we've measured our height, we're on a TLC, and we have our solvents all ready. So we're ready to run this column, and I'm going to start a fresh video for that.